Okay, I'm going to go through section 10 on this video, which is solving inequalities and sketch quadratic graphs to solve quadratic inequalities. And this is question 9, so it's this page. Right, I'm going to go through these three things first, but then I'm also going to kind of talk you through the type of questions you're going to get on the exam, because there's a little bit more to it than just what's on here. Okay, so use these axes to sketch y equals x squared. Y equals x squared basically is just a graph that looks like a smiley face, like that, and it goes through 0, 0. Because if you think about it, if x is 0 there, 0 squared can be y equals 0. So the graph of y equals x squared just looks something like that. Okay. Part B, y equals minus x squared, just flips it down like that. Okay, and then this last one, you don't particularly need to know this for this exam, but y equals x cubed looks like this. Okay, right, so in the exam you're going to be asked about someone's working out to solve a problem like this. Now, what you should be doing here is ignore the fact, right, so ignore the fact that that makes it look a bit trickier because it's got an inequality in it. You effectively still treat this like an equal sign, okay? And the problem that we have here is the fact that our x is negative. So the way that I would solve this is I would add 3x to both sides, which would give me 20 is greater than or equal to 3x plus 8. Then I'd solve it by taking away 8 to give me 12 is greater than or equal to 3x, which means that 4 is greater than or equal to x. The problem with trying to solve this in any other way is the fact that we have an inequality sign there, and when we start to, because one of the main sort of methods with this is multiplying throughout by -1, and we can do that on linear equations, because if we times things by -1, that's fine. It just means that everything changes sign. However, when it's an inequality, it does matter, because numbers kind of work in terms of their size, work in the opposite way. So if I add that 3 is less than 10, that's true. If I times everything here by -1, I end up with -3 is less than -10. That is not true. Okay, so it asks you something to do with that kind of working out. The next part of the question asks you a question like this. It says, on this axis, sketch x squared minus 100. What you should be able to do here is factorise this thing. This is a difference of 2 squares. So can you spot what it will factorise to? Right, well, it will be x plus 10 and x minus 10, which gives us roots of minus 10 and plus 10. What that means is it's going to go through minus 10 and 10 on there, and it's got a y-intercept of minus 100, so down there at minus 100 you've got your y-intercept, which means that your graph is going to kind of go like that. Okay. It will then go on to say, use your graph to solve this, or something like this anyway. Okay. Now, what you have to do here is read this, and this says that you want it when y is less than x squared minus 100. Well, the graph represents x squared minus 100, so we want the bits where this is less than the x-axis, basically. Okay, so it means that we want this part of the graph there. So between which two values of x does that happen? What happens between minus 10 and 10 on my graph? So my answer there will be minus 10 is less than x, which is less than positive 10.